15 people, consisting of 7 batsmen, 5 bowlers, 2 all-rounders, and 2 wicket keepers. The manager chooses a team of 11 players, consisting of 5 batsmen, 4 bowlers, 1 all-rounder, and 1 wicket keeper. Find the number of different teams he can choose. Did everybody get part I right?
Yeah.
What do we need? 5.
5B.
But is everybody cool with part? Part.
Part 5BI.
Thank you.
Can you just do it?
Where we're at right now.
So which part is this?
Part I, part.
BI.
5, yeah, technical difficulties. Okay, so it says on here that we have 7 batsmen, right? We have 5 bowlers.
Mm-hmm.
We have 2 all-rounders, and we have 2 wicket keepers.
1 wicket keeper.
No, for the original,
Oh, yeah.
right? Then it says, the manager chooses a team of 11 players consisting of 5 batsmen.
Mm-hmm.
So they have to choose 5 batsmen. And they have to choose 4 bowlers, choose 1 all-rounder, and choose 1 wicket keeper. Okay? So we initially have to choose, we have 7 batsmen to choose from, and we're going to choose, coming, and we're going to choose 5 of them. So that's the first one you do. Hello? Okay. You good?
Yeah.
Okay, so 7 choose, how many batsmen are you choosing? You're choosing 5,
5.
right? And then what's the next one? I have 5 bowlers, how many do I need to choose?
4.
4, so 5, choose 4. And then I have the all-rounders. I've got 2 of them, I need to choose 1.
Mm-hmm.
And then wicket keepers.
Still 2 choose 1.
2 choose
Yeah.
1, okay? All right, and so what do you have to do with all these? My question is it this or this or this or this, or is it this and this and this and this make this thing? Yes.
It's and.
So what do we do with and?
Multiply.
We multiply. So does that make sense why we would multiply the 2?
Yeah.
I need this, and I need that, and I need that, and I need that to make my team.
Mm-hmm.
Does that make sense to everybody? So these are all going to be multiplied together. So you have your little calculators, you do 7, choose 420 is the answer, right? So when you do that and you multiply them all together, so times, 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 the answer turns out to be that. So go ahead and take a look and see if you know how to put in your calculator right, all that kind of fun stuff.
Yeah. But that I was a little tricky.
Okay, we're going to talk about it. So, technically, does it make sense that this number of 420 is actually every complete possibility that could happen for that team's choices, right?
Mm-hmm.
So that's like the big picture, okay? Now let's look at what the next thing says. Find the number of different teams the manager can choose if one particular batsman refuses to be in the same team as one particular bowler. Okay, so how does that work? So I know that this is, if everybody gets along, this is how it could potentially work. Now we have to figure out how it would look if we have to eliminate one of the batsmen, or perhaps eliminate one of the bowlers. So rather than 7 batsmen to choose from, what do we have? One batsman has decided they are not, right? 6, right? So I have 6 batsmen, and how many am I going to choose at this point then?
5.
Why 4? Because what? Well, because the scenario is, let's say this first scenario is batsmen must already be in this group, right? So you would say, this guy doesn't want to work with anybody if this guy's on the team. So we're going to say he has to be on the team, therefore this guy would not be on the team, or vice versa. So you would have 4 to choose from at this point. because you kind of have eliminated one of your choices. This guy's saying either I'm in or I'm out. Does that make sense? Yes.
So both numbers reduce. So like instead of having 7 batsmen, now you have 6, and instead of choosing 5, you're choosing 4.
Right. Because one is perhaps batsman is in, done. Now I have the rest to choose from. Or the batsman is not in, done. I have the rest to choose from, depending on what we're looking at.
Why do you lower the amount you're choosing?
Yeah. That's,
You put one of them in?
Let me show you.
Yeah, couldn't you do it?
There's multiple ways to get through that.
Okay.
It's hot in here. Is it?
No, it's not right.
It's not hot.
No,
You were singing a song. That's so hot. And then I'll get cold, but then I'll get hot.
mark scheme.
Say it again.
The mark scheme.
Yeah, I pulled up the mark scheme for you all. Okay, so this is the one we're looking at. I think we all understand this part.
Yeah.
Okay. Now, so this is this way, or it could be done this way, or it could be done this way. So there's 3 different ways to attack this problem.
Mm-hmm.
So the first way is to recognize that the first one is these are taken into account. The batsman is going to be a pain in the butt, and who's the other one? Somebody else is a pain in the butt. The bowler is a pain in the butt. The bowler's a pain in the butt. Just kidding. So you have 6 choose 4, and then 4 choose 3, because you're reducing from the grouping. And then why the 2 times 2? Because you still have to choose one wicket, whatever that is, and one of the others. And if you multiply that all together, you get 240 ways that could potentially happen. Subtract it from the 420, and that's your 180.
Wait.
Yes.
How did you know to subtract it from 420?
Because, okay, so 420 is every single way that could potentially happen.
With what they gave
Everybody
us.
gets along, everybody can play with everybody, it doesn't really matter.
Uh-huh.
Then we have restrictions happening here. So we have to take into account the restrictions that could potentially happen. When we have the full everybody minus the restrictions, we have 180 ways that we can make this work. Okay. Or, this is another way. We have, if the bat guy is in, the bowler guy is out. Right? Or, if the bowl guy is in, the bat guy is out. Or, they're both out. This is the way I would have done this problem. I would have said, okay, so let's look at every scenario that could happen. I know that if the bat guy is in, then this guy, bowler guy, can't be in. But if the bat guy is not in, then bowler guy is in. Does that make sense? So the scenario is the batsman is in, but the bowler guy has to be out. So it's 6 choose 4, 4 choose 3, 2 and 2, and so that's here is this scenario.
Mm-hmm.
Moving on to the next scenario, bowl guy is in, bat guy is out. So you would have where are we?
6
Here we
choose
are.
5.
6 choose 3 times 4 choose 3 times 2 times 2, because these never really change. Does that make sense? Or what we do with or, we add them. Both the guys are out. Okay? 6 choose 3, 4 choose 4 times 2 times 2. We're going to add those all together, and we have 180 ways. We don't have to subtract it from the total amount. And then there's another way to go through that process. So you have to kind of figure out which way makes sense to you best. Yes?
Oh, can I find one from the other test?
Sure.
What about like the let's see, October November 2016/62 number 4?
October, November, 62.
This was the test that you like briefly went over.
Oh, okay, so I have that already.
Well, I have it printed out if you want to just.
Yeah, I think I have it printed out over here. Don't I? Shouldn't I? What number did you say?
Number 4.
Okay, so for everybody that wants to look at it. Time taken to cook an egg by people living in a certain town is a normal distribution with a mean of 4.2 minutes and standard deviation of 0.6. Find the probability that person chosen at random is between 3.5 and 4.5 minutes to cook an egg.
Mhm.
Okay. So, how do we start? So the first thing we're going to do is our z-tables. Is everybody cool with setting it up? Looking at your normal distribution curve, and you know it has to be between 3.5 and 4.5. Is everybody okay with that? We kind of did one in class like this where we recognized that if we had this, and we had 4.5, and we had 3.5, and we know we had to be between it, we would have to find all the way back from 4.5 and subtract 3.5 from it. Did that make sense what I just said? So we go from here to here, and then we subtract from here to here, and that gives you that bulk in the middle. Yes?
But then you can't do 3.5 and back, so you have to do greater than 4.5, and then you have to, like, they're like mirror images of each other, right?
You can do 4.5 less. You can do that. But 3.5, you have to find you'd have to go, this should be actually over here negative, but you'd have to find its mirror image over here and find out what it is from behind that. So what would it be behind 3.5? Let's look at it over here.
Well, first you got to convert to
You do have to
z-scores.
convert to z-scores. So the first one is when we're converting, we've got less than 4.5. You see, does everybody understand where the little formula comes from? Right
The
here?
x minus mu over sigma.
Right, is everybody good with that? And that's all given to us, except for the formula, of course. So you have to do your conversion, so z is less than 0.5. Is everybody okay with that?
And then they just found where's 0.5 located on the chart.
Does anybody want to practice that? Look at your chart, look at 0.5, see if you get 0.6915. Actually, I think that might be one of the most frequent ones used. Is that at the bottom, the little thing at the bottom, or not? I could be wrong.
And so that's from everything from 4.5 back.
Less. Is it on the bottom one? No, it's not one, not frequently used then. I thought maybe it was 0.75, 0.9, 0.9. All right. Is everybody good with that? So far, so good? Now let's look at the next one. We're going to do less than 3.5. We convert it. We get negative 1.167. Is everybody okay with y? It's 1 minus 0.8784. Take a look at 1.167 and see where it goes. What do you get for your decimal?
Miss K?
Yes.
I thought you can't do less than 3.5 because it's to the left of mu.
Yes.
So you're going to get a negative.
What would you have to do?
Flip. Well, because isn't like the saying less than 3.5 is the same as saying greater than 4.5. But so in order to find greater than 4.5, we can't do that. We can find less than 4.5, and we can say 1 minus that, and then we'll be left with that, which is the same thing as that.
Right.
Not exactly. He's saying whatever's above 4.5 is the mirror image. Is that true? That's what he keeps saying, like 3.5 and 4.5 are the same thing, pretty much.
What's the mean? 4?
Does it mean 4 or something like that?
Well, what was the mean?
I don't know what the mean was. That's what I was asking.
4.5, right? Or
Does it
4.2.
mean 4?
4.2.
Then
Not
No,
necessarily.
not necessarily. So that's why I was like,
Yeah.
I think you said that because it looks like
it looks like that's
but it's
Yeah.
not. Whatever the z-score is, you gotta find the z. Did you find that yet?
Z.
Okay, let's see. This isn't working for me. There. So you can. Oh my goodness gracious. There it is. So you're going to take this thing and convert it, and you get. Oh my goodness. You get this. You guys try this. This isn't easy. Don't try this at home, kids. So you have negative 1.167. Can I look that up on my z table?
Yes.
No.
Okay.
Well,
Negative.
it's negative.
If you flip the
And,
signs,
but you gotta
You have to flip your
think about
side.
it.
Okay,
Oh.
so do me a favor. Look at your little z-score.
So it's probably that Z is greater than positive 1.167.
So you look it up.
So 0.877, and then you add this 4.
did we decide we can see orange on here or no?
Yeah, we're just probably if the lights are off.
Oh, the lights are off. Okay, I'm gonna use a pencil or something sharp to show. Okay, so, we're gonna use a positive. Is everybody seeing where I'm at, 1.1?
Uh-huh.
Can you see that without me turning around? Okay, so 1.1,
Mhm.
come over to, was it 6?
Yeah.
So here's where we start. So 0.8770.
And then you
But
add on.
it was 1.167, right?
Yeah.
So
You add
there's 7. Come on down. Add 14 to this, to the end of that. So what's 70 plus 14, basically?
.8784.
Right. And there's your answer. Is everybody seeing that
Mhm.
on their little chart? So once we got 0.8784, why do we subtract it from 1?
Because it's who's left.
Because it's on this side of it, right? It's the less of it. Yes.
Okay, so when we're finding something like what you just did, is that only the time we use the top and the side? Because usually we can just use.
So if you use the middle part, they give you the percentage. The percentage of something happening, so that's when you're inside. When they have the mean and all that, and you have to go to find the percentage, that's when you use the outside parts. Okay. All right. So is everybody good with this? Now, why is this happening? That's where I drew it over here earlier. So it's this whole thing minus what we just found, which is this thing. Sorry, which is what's left over in between. Okay. Is everybody seeing that?
So let's see. So when you're less than negative 1.167 is the same as less than 3.5. And if you subtract it from 1, then you're getting greater than 3.5.
Right.
And then we did there, for, which was 0.1216. And then you do the other one minus that, and you're just going to be left with this stuff in the middle.
In the middle.
And that's
Right.
what we want.
That's right.
Yeah.
Is everybody good with that?
Mhm.
Like crickets. Somewhat good. So that was odd. We're 3 points. What's the next part ask? Now, this one says 12%, so it's giving me a percent. So I'm probably going to be working in the middle of the chart, right? So 12% of the people take more than T minutes to cook an egg. Find the value of T. Okay? So 12% take more than T minutes to, so what do I have to do? More than T minutes, 12%. So what do I do? What do I do in this case?
You find like where 12% would be in here, and then find the z-score that corresponds to that.
Okay, so where does 12%, how do we find 12%? How do we write it, first of all?
0.12.
0.12, right?
Yeah.
Yeah. So go ahead and look on the little chart. Now, can we find 0.12? Can
No.
we find the things to the right of it? No. So what do we have to do? We have to look at the corresponding part.
Yeah.
So what would 0.12 be? 1 minus 0.12 is what?
0.88.
So go ahead and look up 0.88.
And you have to find the, if you can't get right on it, you want to try to find as close as you can to
Correct. You go under it first, right?
So 0.88. $1.175,
Yes. Okay.
and you get right on 0.88.
Is everybody cool with that? Does everybody see how we did it? We know we can't go above 0.12, so we have to look behind it, which is the other whatever percent.
So if we don't do the add-ons on the test, we'll get it wrong, right?
They would like you to do the add-on. Did you do add-on for this one?
Yeah, you add on.
You had to add on because you were underage a little bit, right?
by
Yeah.
10, so
Yeah. So then you needed to do it, right? So is everybody? But look what they wrote. They would accept 1.17 to 1.18. Okay. So that tells me they're pretty cool with whatever. But, yeah. Okay. So now does everybody understand why it's 1.175 equals t minus 4.2 over 0.6?
Because x is the same thing as t in this case.
Correct.
Yeah.
And what do we have here? 1.17 is a z-score is equal to whatever x minus the mean is over the standard deviation, right?
Yeah.
So that's our little formula. So then you start to solve, and you get t is 4.91.
Mhm.
Yes.
How do you know it's 0.88?
How do we know it's 0.88? Okay, so you see 12%. 12% is representative here's my line. Let's just say this is 12%, 0.12. Is everybody good with that? Can I measure something to the right like that? No.
No.
I have to do the stuff to the left of it.
Okay.
So what's the left of it? How do I get 0.88?
1 minus 0.12.
Right. Does that make sense now? Cool. All right, is everybody okay with that one?
Triple I was a little tricky.
Yeah, and you know what? It kind of bothers me because you will not have learned, you don't learn logs until the next level.
So why are they including
That's my
logs?
question.
Is there another way to do this problem?
So let me look at it. Hello? I'm good, how are you? I'm teaching. Yeah. A sample of n people is taken. Find the smallest value of n if the probability that none of these people take more than 2 minutes to cook an egg is less than 0.0003.
Mhm.
So the result, why would they use 0.88? Because you can't go that way.
N.
And it's less than, and we don't know n, is less than 0.0003
Is that point A to the N? Or
to the nth power.
Okay, okay.
Yeah. I don't like it because you have not been told how to use inequality or power correctly placed using n.
Or 1 minus.
By
But you
logs.
still would have to use logs or guess and check. So here's how this works. I can't imagine why. Well, have you seen logs before?
I think in algebra 2, right?
Logs are pretty cool. So the way it works is I use the ln button instead of logs. They'll give you the same answer. If I have something, this might be good for you for SAT purposes anyway. So if I have something that looks like this, and I'm trying to solve for n, let's look at it with something we are aware of. For example, 2 to the n is equal to 4. Okay? You can tell me right now, you know that n is 2. Would you agree? So it's not hard, you see that. So the idea is 0.88 to what power gives you 0.003. Now,
Yeah.
that's a really hard guess and check kind of thing. So here's how this works. If you take something called the natural log, and you look at your little calculator, there is an ln button on there. Do you see it? It should be at the very front. I use natural logs because typically that's the one that's on the face of the calculator. If you take the natural log of both sides, if you do something to one side and you do it to the other side, does it make sense to you that you haven't changed it at all, right? And one of the rules for logs is that exponents, once you have the natural log in front, can be pulled to the front. So it would be n ln of 2 equals ln of 4.
So you found an element 2 and element 4 and
And you solve like you would naturally. So you're going to find this value and divide it by this value, and you're going to get your answer. You should get 2. And we know that it's 2 because 2 to the second is 4. Yes,
So doing ln to both sides is kind of like doing arc cosine to both sides.
absolutely. You're not changing it at all. So that's, I mean, regardless if you're going to get 3 points out of this problem, the fact is, what if you had 2 to the n power is 9 on an ACT exam, for instance? So how would you go through that process?
ln both
You
sides?
You would ln both sides. You could guess and check with that one because you know the answer should be about, whatever. So ln both sides. So if I ln both sides, so ln of 2 to the n equals the ln of 9. Remember that the exponent can come to the front. And divide that out, what do you get? 2 to the what power is 9? Well, 2 to the third power is 8. And 2 to the fourth power would be 16.
So 9 halves?
So it's a little bit less, yeah, it's like 3 point something. 3.17. So n is 3.17, which is not a bad thing for you to know how to do when you go to take these tests. Yes.
So what do you do with the ln's when you get n ln 2 equals ln 9?
Well, because you're plugging in your calculator, it's going to take the answer for you.
No.
Yeah.
They're wrong, because if you plug that in, you get 45.4.
Because you're talking about people, the
And
population of
it's greater
people.
than 45.
Okay.
So let's go ahead and do that. So you would ln both sides.
But you pull the end.
Right? You pull the end of the front by properties of exponentials for logs. And once you pull that to the front, you would get n, the ln of 0.88 is less than ln of 0.003. So you take ln of 0.003 divided by ln of 0.8844, yeah. So n is less than, is it less than?
45. Greater than.
Greater than, sorry, I started off wrong altogether. Greater than, greater than, greater than. 45.4.
It's just talking about
You're
people.
actually, the top one was correct, 0.8 was actually correct. It's supposed to be less than.
Okay. Well, but shouldn't have changed it over, unless you're dividing by a negative.
That's what, they changed it over there, they had it the other one.
Oh, was the original greater than 0.12%? The question?
Maybe?
Yeah.
Oh, yeah, that's good.
So, okay, so why would we flip it over there?
Because you can't do,
Because you can't do the things to the right, you have to go to the other side. So that 0.88 is the, basically the negative of it. So when you divide by a negative, you flip your sign. Okay. And again, that probably would not be one that you would get 3 points for, because you have not been introduced to that until you get to ACE Path 2.
So why do they test you on it?
I don't know. I don't like that. So far, though, of all the tests we've done, I think that's probably the only problem that we've seen that
No,
really...
It's not that bad.
It's really not that bad when you're introduced to it. LNs are really...
It's just when you see it, you're like,
Yeah, like I've never seen an LN before. But for future reference, anytime you want to find what N is when it's a power, that's a really cool technique to use. All right, are we good so far?
Um,
can I read a question and see what I'm just just so I can recognize it?
Well,
Like, if you have questions, you'll take look like read.
yeah, you want to do the question.
do you mind if I pick another one from another test? May, June 2016, number 5, II.
Okay, let me find it while she's looking. Did he say he did it?
Yes, if this is headers, so you can give me a slash grab and I'll do it, because I don't know. Okay, when you're gonna come by the school and drop off the slash grab. Like, I have the laptop.
Oh, you heard it.
That's the thing, that's the other thing.
Ways to go. May, June 2016,
May, June 2016 /61.
61. Tomorrow we'll be together and Wednesday, so we're good, right? Keep working on these problems, please.
This is due Thursday.
Do what?
I think this is due Thursday.
Thursday.
So we'll be able to turn it in if they.
Yeah.
Just open your door since you won't be here.
Yeah, just don't turn it in after school under my door because they have a tendency to get thrown away. I did have somebody turn it in to find it. There it is. Okay, go ahead and look at it, read it, and then we'll kind of talk about it.
The one I had circled was II, so I guess II understood how to do, but II was a, because it switches. It's actually a binomial distribution for II.
In the middle.
Yeah,
Okay, let's talk about that.
the first one is a normal distribution, and II is a binomial
And it
distribution.
flips to-
But it's binomial, but they're using. It says X is a binomial distribution, and is also a normal distribution. So it's confusing.
That is confusing. That's the second one we've seen that does that, though. So, okay, your plastic straws are manufactured to fit into drink cartons, which have a hole in the top. A straw fits into the hole if the diameter of the straw is less than 3 millimeters. The diameters of straws have normal distribution with a mean of 2.6 and the standard deviation of 0.25. A straw is chosen at random. Find the probability that it fits into the hole in a drink carton. Okay, so let me go ahead and pull this over
You have to convert it to a z-score first.
right? So the probability of less than 3.0. So is everybody cool with remembering how to do that? Taking 3.0 minus 2.6 divided by that. And so go ahead and check out probability z is less than 1.6 on your little chart.
You get 0.95. Well, no, 0.945. Yeah.
And that's your probability. So is everybody cool with part I?
Yep.
So that's pretty good stuff. Okay, 500 straws are chosen at random. Use a suitable approximation to find the probability that at least 480 straws fit into the holes in the drink cartons. So how do they convert this into a binomial all of a sudden?
Because you've got like success and failure.
Yeah, it fits or it doesn't fit. What
Uh-huh.
else?
It's they're independent.
They're independent of each other. So I put the first straw in, it fits, good to go. Put the next straw in, did it matter if the first straw fit?
No.
No, so fits or not fits. It's independent of what happened the first time, or the second time, or the third time. Does that make sense?
Yeah.
What else?
There-
There's limited, there's 500, but
There's-
it's still a lot, but limited. It's not millions.
There's another criteria.
Yeah, yeah. We're just looking at the question for now.
Oh, the question, okay.
Yeah, just for now. We're trying to figure out, this initially was a normal distribution, right? And then all of a sudden, the answer key scroll kind of became a binomial. And we're trying to justify, could this be now considered a binomial? So the criteria to make a binomial is that it's a success or failure, so fit or don't fit. It's a limited number of trials, 500 pretty limited still, right? What else? Independent of each other.
Mhm.
If the first one fit, does it matter if the second one fit? Does it matter, that kind of thing?
Yeah.
And then what's the last one? What's the last? What?
I think the last one.
The last one has to do with the probability of, success or failure is the first thing we said.
Yeah.
So is it a constant probability every time? It is, right? What was the probability that it actually fit in the hole? What was what we just found?
Yeah. But they've got like binomial and normal distribution like jumbled up together. I'm not sure where they're getting 472.6 from.
So they have the binomial is 500 and 0.9452, which is what we just found here.
Uh-huh.
Z is greater than Did they do it either way?
They only had one method.